Okay. Speed of ultra waves. Yeah, this ultrasonic waves. Okay. I think it is around in air. Okay. So we have about 340 meter per second. Actually, it is around 343 point something meter per second. It's saying that we have a speed of, let's find out. We have a speed of 340 meter per second. Okay, remember the symbols. Okay, so we have the speed of 340 meter per second. Okay, and we can calculate the time with the help of the sensor. Okay, so we'll get the time. We can calculate the time. Okay, so what we will get? We will get distance. Okay, we will get the distance, and our equation is completed, and we are able to get the distance. Okay, any doubt in this? Hello. If you don't have a doubt in the comment box, if you have a doubt, then you can have your doubt. Noise. I think actually our office is near to the main room. That's why it has some background noises. But I'm sitting in the isolated room, so I don't think that much voice is coming. Okay, I will speak louder. Okay. Anyone has doubt in this distance formula and how we are calculating in distance? No. Okay. Mohit say no. Okay. Anyone? Yes. No. Anything? Others are sleeping in the class. Guys, come on. I want to be attentive in the class. Okay, right. Okay. Okay. I think that. Check your head. I am not saying anything. Okay. Let's continue. Okay. So we have calculated how to calculate. Okay. So now time for making our circuit and making things. Okay. Okay. So what we will do now, we will have an Arduino. Just I will type it. We will just have an Arduino. Okay, here it is. Let's show. Okay. So first we will calculate the time. Okay. So first we will calculate the time with the help of Arduino, and we will print it on the serial monitor. Okay. So as you see, I have this ultrasonic pixel. Let's make it close so that our circuit is very easy to hook up. Okay. No, I think it is not that much. Okay. Let's copy this. Okay. Paste. Okay. Just remove the edge. Okay, and here we need height. Okay. So we have this height, and the place of this 13 we need that trigger pin. Okay, so first we are lowering that trigger pin, then we are making it height, so it has a variation. Okay. Otherwise our sensor cannot distinguish between the first uh, uh, but the first signal and the last signal. Okay, So we're using here delay, and in this time we are not using only the in millisecond. Okay, with this time we are using the microsecond, so I have to mention the microsecond. Okay, so I'm writing micro. I see micro microseconds. Okay. So we have this in the microseconds, and we require how many microseconds? We require 10 microseconds. Okay. Okay, so we have a 10 microsecond waiting for 10. So we are waiting for 10 microseconds, okay, and then we are again making it high, and then we are again making it low for 10 microseconds. Okay, so I will just copy this and I'll just paste it again. I'll copy whole of this statement. Okay. Copy and I just paste it here over the statement. Okay, so you can see that we are just making it low and then making it high, okay, and then again making it low. Question is why we are doing it again and again. Okay? So why are making it high and we are then making it low, and then we are making it low then high and low, because if you can see, okay, so uh, okay, so first, okay, so to differentiate between the waves, okay, so suppose we
ये
set the
रिपोर्ट
first.
से घंटों तरी भी टाइप होता है
Okay, so if something obstacle is in between, okay. So suppose it was continuous wave is sending here to here, okay. So it's sending continuously, okay. So we cannot differentiate between the first wave and the second wave. Suppose object comes to near, okay, our sensor comes near here, okay. Or if the object comes to near, then also it's sending us the same signal, because the pulse is continuous. Okay. So for that purpose, what we do, we break the pulses. Okay. So we send the pulse. Okay, and then we make it stop. Okay. After some time it get better. Okay. After that we send another pulse. Okay. Another sound wave, and then it's back again. Okay. So we are what we are doing is we are turning off. Okay. We are turning for a small second. Okay. And if suppose it's a trigger pin. Okay. This is trigger side and this is the receiving side. Okay. So so what receiving is receiving nothing. Okay, then it send a signal, we are offing it, and it received at a certain point. Okay, it's received and it noted that it has received. Okay, then we again send the signal. Okay, then we again received it. Okay, so at every interval we are sending and receiving it, and the interval is very short, that okay, it is 10 microsecond. Okay, so microsecond is 10 to the power 6 minus 6. Okay, one it means that 1 upon 1 crore. Okay, 1 upon 1 crore second, or something like this. Okay, so it is a very short period of time that we are making it on and off, on and off, and in this short period of time we are measuring the distance and we are calculating the time. So we wait for. Okay, so we get till now. Okay, so we low it. Okay, now time to calculate time to calculate what we are getting it. Okay, we need what we are getting it, the time we want, the time. Okay, so we take the time with the help of this variable which we have created our. Okay, so sorry, we have this variable called, sorry, variable. Okay, so we have this variable and we copy this. So we have ping time. Okay. So we'll store what we will store in this variable. We'll store the time. Okay. So for getting the time, we have a formula. Okay, we have function. Okay. So what is pulse in? Okay. Call it pulse in, and what it do? It it gives us echo pin feedback. Okay. So it is a echo pin slash high. Okay. So when till the time the echo pin is high. Okay. Okay, it tells us. Okay, so it is reading the pin number. This okay, it is reading the pin number 11. Reading the pin echo pin. It is reading the echo pin, and that how much time it is high, that is storing in this pin tables. Okay. Okay, so we have that. Okay, and we need to give a delay. Okay, so we are giving it a delay so that we are giving it a delay for 25 milliseconds. 25 milliseconds is also very small time just to see the reading on our serial monitor. Okay, we have done. Okay, no, we have not done. We have still now not printed it. Okay, so we need to print it. We need to print it. Okay, yeah, serial. हाँ ठीक है मतलब मैं वही बोल रहा हूँ कि आप 20 कुछ लीजिए सो ही है लेकिन कोर्स से जन्म का पहला तो लाइट क्यों ऑन करता है पहला तो जब आप लोगे serial dot print. Okay, this is serial dot print print Allen. Okay, so Allen means that it will change its construct every time. Okay. Okay, so we have serial dot print Allen, and what we want to print? We want to print the spring time. Okay, so how many time it is taking? Okay, and remember this. Remember this is in the microseconds. Okay, we have this, and so this is in the microseconds. Okay, everything saying that we have done something. Sorry, it seems to have an error. Okay, we have some error. Delay dot microseconds. It's okay about okay. Okay this time. Why? It's fine. It's fine. Delay dot microseconds. I'm getting it. Stop. Showing. Okay, so I copy this and I'll have it in my copy this and I'll paste it in my what we call Arduino. So it will tell me what the error is. It's taking a little time. So we have a new file. Okay, so I'm just I got it. I just make a printing mistake. Okay, so it's micro ICRO, not micro. Okay, so that's the mistake. Okay, let's correct it. Okay. So here also, I think everything is right now. Must okay, must be thing is something. Let's compile again. See it. You see something. Okay, so here also C is missing. Okay. So see, I have copied everything. That's why it's the micros. Okay, it changes its color. Okay, now everything is fine. Let me compile it. It's running fine. So I think it's right now. Okay. So it's done. So let me just change this here also. So we have MICRO. The C is missing here and C is missing here. I think there's a problem of C. So it's working. Okay, now it's working. Okay, you can see the serial monitor. So we have this. Let's show. I will show you something. Make it a little small. Okay, let's make it. Mhm. So it's not. Okay, that's fine. Let's see our code. Okay, so we need okay, so you can when I click here somewhere here. Okay, so it's not signal clear. Not printing anything. It's not printing anything. We have serial dot begin. We have everything right. Okay. Stop this. I think this chemical thread is not working. I have another back circuit there. Okay, I will show you. Code. Code. We have serial. Roughly working. Roughly signal in travel time. Echo high. Receiving signals. Okay. Right. Exactly. Okay. So I have a okay. So I have a circuit before also that. Okay. So that's circuit. Okay. So we have the circuit. And I will show you. Okay. We have the same circuit, the same length and all. Here we are calculating the distance. So it has almost the same thing. Okay, if I show you this code, okay. So what we have done is we have just printing this distance also, okay. But previously we're not doing it. Let's just simulate it first, then I will show you how it's doing. Okay, so it is showing the distance. Okay, so this is okay. Okay. So it's a little bit small. Suppose this we have this. Okay, so suppose you can see the distance. Okay, so we have a line. Okay, so we have 166 and 146 centimeter. It's showing 144 centimeter. Okay, so it is measuring the distance. Okay, it's working here. Okay, it's not working the same thing. Okay, fine. So I will stop it. Okay, so it is same code. Okay, let me print the pulse in. Okay, for you, I will print the pulse in. copy this and I will paste it here. Okay, and I will use microseconds. Okay. Just stop. Okay. So you can see. Okay, so we are getting microseconds. Okay, we are getting that. What's that? 180 microseconds. 180. Okay, so we are getting the time. Okay, so this is the time in microsecond. Okay, so converting this time. Okay, and we know the speed. Okay, so we are using the distance. This is the speed. Okay, this is the speed, and this is the time. Okay, so I will. So we are getting the time. Okay, so first we get the time. Okay, then we convert this that time multiply by speed into distance. Okay. So how we are doing this? How this number is coming? Okay. This one. Okay. This is the number. Okay. So this is the number. This is the formula. Okay. So this is nothing but speed into time. Okay. So this ping travel time is your time. Okay. And this number is your speed. Okay. So from where this number has came? Okay. So 0.0345. Okay, so where this number has came? Okay, so this is the main question, where this number has came. For getting this number, as we know that our speed of sound is 3 something, this is 3443. Okay, so 343 meter per second. Okay, so but we required okay, and the time we have is 34 meter per second multiply by and here we have a microsecond, so we are getting that 800. Suppose we are getting that 80309 microsecond ms. Okay, so we are getting, okay, so we are getting something like this, and this is our distance. Okay, but you can know that we want distance in centimeter. Okay, and this is in meter per second. Okay, and this is in microsecond. Okay, so with the because of this unit we need to change this this value. Okay, so we need to change this value, and how will change this value I will show you. Okay, what we are doing is, so we have 343. Okay, so we have this, sorry, let's make it 345. Okay, so we have 345 meter per second. Okay, and we required it into centimeter upon microsecond, so that it multiply with microseconds, and microsecond cancel out, and we will left with centimeter. Okay, for that purpose what we are doing is, first thing we are doing is, this is meter per second, so 345. Okay, as it is. Okay, we know 1 meter is equals to 100 centimeter. That's right. Okay, that's very basic facts. Okay, so we can write 1 meter upon 1 meter. Okay, so 1 meter upon 1 meter is, if we divide 1 meter by 1 meter, we will get 1. Okay, this is nothing. Okay, if we divide this by this, we will get 1. So we can multiply this. Okay, so we can multiply 345 by 1. Okay, we can multiply this by 1. So we can multiply, let's make it better. Okay, 3, 4, 5 multiply by, so we have 1 meter per second upon 1 meter per second. So what we'll do, we'll convert this. Okay, so we'll say 100 centimeter. Let me clear all everything. Okay, so have a proper, with the mouse. Okay. So here we have a mouse. Okay, what we have that, we will what we'll do, we um, we use a notepad for that purpose. It's not clear. So we use the notepad. Okay, we use the paint. I think that's a better option. Okay. We will text also. Okay. Text also. So we have 345. Okay, so we have meter per second. Okay, we will multiply it by, so we have a multiply with the help of x. Okay, so we multiply it by 1 meter divided by 1 meter per second. Okay, we can write it like that. Okay, or we can write it like that. You know that 345 meter per second. Okay, multiplied by, okay, so 1 meter is equals to 100 centimeter. 100 centimeter divided by meter. Okay, so 100 centimeter divided by meter. Okay, so now let me have a I will use this pencil. Okay, so this meter. Okay, so these are in upon, so this meter divided by this meter is cancel out, so we'll left with 3. Okay, let me use a tax also. Okay, so okay, so you will left with 345, multiply, when we multiply by 100 you get 100. Okay, and then we left with centimeter per second. Okay, so now we have cancelled that meter. Okay, and we converted into centimeter. Now we need to convert this seconds into microseconds. Okay, so we again multiply it by 1. Okay, so we are again multiplying it by 1. So we know that one 1 second equals to 1, 2, 3, 4, 5, 6. Okay, so microsecond. Okay, so this much. Okay, what we are doing now is, now we are just doing this like a meter per second, then we are converting this also back to uh, microsecond. Okay, so we have this and we are dividing it by. Okay, so understand one thing, that we have that microsecond above. Okay, so we have meter above, so that's why we are multiplying it with above. Okay, now we have seconds down, so we should multiply it with down. Okay, so what we will do, we will multiply it by 1 divided by 1, 2, 3, 4, 5, 6. Okay, so which is equals to 0.0345. Okay, and the unit of this is centimeter centimeter per microsecond. Okay, so we get the centimeter per microsecond. Okay, and we multiply it by our microsecond. Okay, and multiply it by ping time. We use a ping time. Okay, so we have ping travel time. You know that we have created that variable. Okay, and that is also in microsecond. Okay, so let's make it dot. Okay, so what happened that when we did that. Okay, so this microsecond cancel out this microseconds. Okay, and we will get in everything in the centimeter. Okay, so that's we are doing here. Okay, so we are this is speed. Okay, so this is a speed in centimeter per microsecond. Okay, so we have a speed in centimeter per microsecond, not meter per second. Okay, not in kilometer per second or kilometer per hour. We have this speed in meter per microsecond, and we multiply it by microsecond, we are getting this. Okay, why 2? Why we are dividing the time by 2? Because uh, our rays get reflected back from this place. Okay, so our ray comes there and go back. Okay, so it takes to double time. So object is in a closed place, but sound travels and they get reflected back. It means that it is taking twice the time it reaching the object. Okay, so that's why we divide it by 2. So when we divide it by 2, okay, when we divide it by 2, we get distance. Okay, and we will print the distance here. Okay, this time we are not printing the time, we are just printing the distance. So we're getting the distance, and let's see what distance we're getting. So let me clear first. Okay, so let's clear everything. Okay, okay, so not ms microsecond, meter set. We have it centimeter. So let's do this. So this yeah, centimeter. Start. Okay, so we are getting is 26 centimeter. Okay, so see the accuracy. 24. Okay. Okay. So So there is an error of 1 centimeter. That is okay. We can have an error of plus and minus 5. So sensor have a little bit error, but it is almost okay. So we have a centimeter one. We can use that. We can use that okay. So I'm sending this code to you. Just 1 second. Copy. That's when you can stop recording.